Okay, we're going to take a look at our alternate examples for section 1.1, where we just start to look at getting data organized and even some very basic summaries. Sometimes categorical data, sometimes quantitative, but for the most part, I think we have quantities, we have numbers, but most of the data here is categorical, right? Our variable of interest here is major, right? And you have business, social sciences, and so on. And then they have the number of degrees from those, and then percent of degrees. So it kind of gives us a breakdown of what everybody at this college is majoring in. So one of the things that might be helpful in looking at something like that, if we have a percent breakdown like that, would be like a pie chart, a circle graph. Sometimes circle graph's not appropriate, but we want to start to think about that, when and why would it be appropriate or not. So the next example we have here is type of personal information on social media profiles, right? So they break it down into several categories. Photo of themselves, school name, city or town where they live, and also the email address. So we want to make a bar graph of this. We could do this by hand, but I think the quickest way to make a bar graph is with Excel. If I just highlight this entire table, I can right click and press copy, or I can hit Control C and press copy. And then when I come over into Excel, I can just click in any box and press Control V, or right click and press paste. Bar graph is very easy to make in Excel. It takes a lot of the heavy lifting away rather than having to do it by hand. So I just highlight the table. I'll show you how easy this really is. And up at the top here, you're going to see a tab that says Insert. That's the one I want to get. So I want to make sure my table's highlighted. I go to the Insert tab, and then I just find the bar graph right here. I click on it and just tell what kind of bar graph I want. Do I want a segmented one? I'll just take the basic bar graph. And Excel makes that for me very nicely and neatly, and I can copy and paste this very easily into a Word document if that were something I needed to do, if I was working on something like that. So that's a pretty well labeled bar graph. And would it be appropriate to make a pie chart for these data? Again, let's try to consider where these data came from, right? Here are the percentages of 12 to 17-year-olds who post various types of personal information on their social media profiles. So that's the type of data that we're dealing with. And here we have the percentages, right? Type of information that they posted, and then the percent breakdown. So let's think about the second question. So the easiest way to think about whether the percentages would make sense in a pie chart is, this is just like what percent of people 12 to 17 post these photos, not what percent of their posts are photos, right? So the other thing I can do is just look right away. I can see these percentages don't add up to 100. So a pie chart would not be appropriate for this because they're not parts of a single whole. It's just, the percentage of time that these folks make those particular posts. So pie chart would not be appropriate in that situation, okay? Here we have a basketball example, and these are statistics for Dwayne Wade. And they're telling us that he averaged 7.5 assists per game and 2.2 steals per game. They provide a graphic and wonder, do we think that the graphic is appropriate? So the answer is already written out here, and the truth is he averaged about 3 times as much, or 7.5, 2.2 times 3 compared to 7.5. Whereas when we look at those graphics, our attention is not drawn here. Right, I don't necessarily think to look at the heights of the two figures. Right, my attention's not necessarily drawn to this number and this number, which it ought to be. I'm more apt to see the area of these two basketballs, and it's a little bit misleading. It looks like he's made many more assists than steals. So that would be the issue with that graphic. Okay, so now we're going to look at the cell phone data here, and maybe perhaps some vocabulary that's not really familiar to you. So a couple things that we're going to talk about here is a marginal distribution of a variable, and then also the conditional. So when I have a two-way table like this, it's split off of 2 pages here, but I have people that are 18 to 34 years old, people that are 35 to 54 years old, and people that are over 55. So in this age group, what do we find? 169 had iPhones, 214 had Androids, and 134 had something else. Okay, so for a total of 517. Then I look at this group, 35 to 54, 171 of these folks, 189. So just to point out something real simple that I think anybody can understand. This number 171 is clearly bigger than 169, but it really doesn't mean anything to me that it's bigger than it, because the total of people that were 35 to 54 is bigger than the total of people 18 to 34. So what's more helpful for us in this type of situation is to look at percentages, okay? We can do that two ways, right? We can look at just the percent breakdown of iPhone, Android, and other, right? We can say 467 out of the total 2024 had iPhones. 503 out of the 2024 had Androids. And then 1,054 out of the 2024 had something other. We call that a marginal distribution, because what did I do? I grabbed my numbers from the margins. It gives me a breakdown of who has what types of phones out of the total. That's what we will call our marginal distribution. And that would be, for starters, a much more helpful way to look at these numbers. Now, if I move down a little bit and look at the question that they ask, and that is the first question that they ask is going to be the marginal distribution of just cell phone type. It's basically what I had just broken down for you there. So for a marginal distribution, I would want to just simply think about what percentage of people are using the iPhone, what percentage are using the Android, and what percentage are using the other. So how do I do that? For iPhone, I take this 467, divide that by the 2024. For the Android, I take the 503, and we divide that by 2024. And for the folks with something other, we take 1,054 divided by 2024. And then I can easily convert these to percentages. Okay, so right away I have a much more helpful breakdown here to see 23% versus 25% versus 52%. That's my marginal distribution, okay? So what does it show? The percent who own iPhones and Androids are about the same, but more than half own something other than one of those two. That's the most eye-catching summary that we can pull from that. So if we take that same data and we put it into a bar graph, you can see that's what we have here in the bar graph that I left on there. This is our 52%, and we can see the major and minor differences in comparing that data. Okay. Now we want to use the cell phone data to calculate the conditional distribution. A little bit different word there now. Conditional of cell phone type for 18 to 34-year-olds. So I'm basically doing the same thing I just did, but I have the condition on this that I'm only really interested in 18 to 34-year-olds. So what does that look like? Okay. Now I'm just going to say amongst the 18 to 34-year-olds, that's all I'm really taking a look at. I had, for the iPhone, we had 169 out of 517. See the difference? I only care about the 18 to 34-year-olds, so that my denominator becomes different now. Then we have the Android. And what happened there? There's 214, again, out of the 517. So the big change there is my denominator. If it's a conditional distribution, they're adding a condition on it. The condition here was 18 to 34-year-olds. And then finally, we have the other, and that would be 134 out of 517. And of course, I can do the same thing. I can make that into percentages. Now, what's going to be really helpful is I'm going to do that 2 more times. I'm going to do it for 35 to 54-year-olds, and I'm going to do it for the 55 plus, right? And then I can look at those 3 distributions. That's what I want to do next. So let's see what that looks like. So the question the statistician likes to ask here is, are the 2 variables related? Does it appear to be a relationship between the 2? And we can see when we look at these marginal distributions, I showed you how to calculate the first one right here. This is the one that I just did. My red pen. That's the one we just did, and we converted to a bar graph. So we can do that for the 35 to 54, and we can see that amongst those younger age groups, the distribution's a lot closer amongst the iPhones and Androids And in fact, the younger folks are much less likely to be part of the other. But we saw in the overall distribution, an other phone was the most likely, and we can see where this is happening. It's mostly influenced by the 55 and older group. Therefore, a statistician would look at something like this and say, yeah, there does appear to be an association between age and the distribution of cell phone usage.